use elimination. The first step is you add or subtract the equations to eliminate one variable. This doesn't always work. This only works if it is set up already. So in these first problems, they'll all be set up, and we can start with step 1. This example shows you what set up means. So we have here 3x plus 2y equals 7, and then we have 5x minus 2y equals 1. So when I say set up, what I mean is that you have one of the variables has the same number in front of it for both equations, and one's a positive and one's a negative. So we have that right here. We have, get my pen here, have a plus 2y on the top, and we have a minus 2y on the bottom. So what happens when I add these two equations together is 2y minus 2y is 0. They cancel each other out. So that's what we want for elimination. Sometimes, like you'll see in a little bit, you have to make it look like that first. You have to do a little more work. But in these first few problems, it'll already be set up, and all we'll have to do is add them together. So in this one, when you add 3x plus 5x, you get 8x, and then the 2y minus 2y is 0, so you just get 8x equals 8, and you can solve that really quick, divide both sides by 8 to find your solution. Now that's only part of the solution, of course. Then you have to do the same steps you did before. These are exactly the same as they are for substitution. You have to take what x is equal to, plug it into one of the equations, the original ones, doesn't matter which one, and then you solve and find y. Sometimes that takes considerably more work than the first part of solving for the first variable. Once you find your solution, you should check it. You can either check by plugging both the x and y values into both equations, or you can graph it and see if these two lines did indeed cross at the point 1, 2. You have an additional step first before you can go ahead and do that. And the additional step is usually to multiply both sides of one of the equations or both equations so that you can get that plus 6y minus 6y. See, on number 9 right now it's minus 3y. So we can't add these together yet because you would get, if you added these together now, you would get 7x plus 3y equals 80. That doesn't help us because we still have an x and a y. Our goal in solving systems is to get one equation with one variable so that you can find the value of that variable and then go back and find the other one. All right, so let's pick one of these. Number 6 is started for you. They already added, all they did was write the plus sign. So they showed that you're going to add these together, and 2x plus negative 2x is 0. 1y plus minus 3y is negative 2y, or 1y minus 3y. And then we have 1 plus 5 is 6. So you're almost done solving for y already. So you'll finish, you'll find what y is equal to, and then you still have to find out what x is equal to by taking your value of y and plugging it back into one of your equations. All right, let's look at the ones that are a little bit more work. So we are going to have to solve these for a variable, or I mean, make one of these match the other one. So in number 9, I need to either have both the x values the same, the coefficients in front of the x the same, or the coefficients in front of the y the same. And it is better if one of them is a positive and one of them is a negative. So the easiest way to do number 9 would be to multiply both sides of the second equation by 2. Because if you do that, you'd have 2 times 5x is 10x, 2 times negative 3y would be minus 6y, and then 88 times 2 is 88 times 2, 176. Now I can rewrite the second equation. I'm just going to put it above it. Didn't change anything with that one. Now if I add them together, look what we have here. Plus 6y minus 6y. The y term will eliminate, and you'll just be adding 2x plus 10x, and it'll be equal to whatever negative 8 plus 176 is. So you'll be able to find the value of x quite quickly. Let's look at number 10, where your mistake was. Number 11 you can solve with either elimination or substitution. I'm going to show you a little trick on number 11. You could solve it for y because it's y is by itself, but you will have a fraction, and some people would rather not work with fractions. So you could also do this. You could multiply both sides of the equation by some number to clear the fractions. So you could multiply by 2, because 1/2 times 2 is 1. Or you can multiply by 4 if you wanted, or any even number will clear the fractions. I'll just go ahead and multiply both sides by 2, which 2 times 1/2, or in other words, 1/2 of 2, is just 1. So I'm just left with 1x. 2 times y would be 2y, and that's equal to 4 times 2 is 8. And look at, what do we have now? We have it set up so that you could use elimination. So you could real quickly solve this by eliminating the variable that has a plus 2y and a minus 2y. Those would cancel if you add it together. Or you could do substitution. You could solve the top equation for x, because 1x is the same as x, and you could then, you'd say that x is equal to 8 minus 2y, and then you could proceed. So there's a couple different ways to do that one.